Okay, so functions question. First of all, we need to understand this represents the inverse function. So we're going to go ahead and write down y equals 2x plus 1. You can interchange the x and y right away from here, or you can just rearrange to make x the subject, right? Subtract 1, and then divide by 2, divide by 2. But then you need to rewrite that in functional notation. So the inverse function asks that you take an input, subtract 1 and divide by 2. Okay. Of course, the alternative method might have been to interchange the x and y from here, then go ahead and solve for y here. You would get the same end result. Now let's have a look at the next one. This is a composite function, so it's important that we grab this guy first. So f of -2, we feed the -2 into the f function. The f function says 2 times by the input plus 1. So that would be -4 plus 1 is equal to -3. And now we can replace this guy here with -3. So we're going to do g of -3. And the g function says 3 times the square of the input, subtract 4. So that's 3 times 9, subtract 4. You can see that's 27 minus 4 is 23. F of g of x, this is a composition of functions. So x goes into g, and what comes out? Well, what comes out is 3x squared minus 4. That's g of x. Now this gets fed into the f function. Now got to think carefully. The f function tells us f of whatever we put in, we have to do 2 times by the input plus 1. And this is a good way of thinking about it, right? So into the f function, whatever we put into the f function, we times it by 2 and we add 1. And so can you see that this 3x squared minus 4 in this box here is what we feed down here. So that's 3x squared minus 4. Now technically that'll be a bracket. We can go expand 6x squared minus 8 and then plus 1, which is 6x squared minus 7. So the composition function f of g of x, or f of g of x, is this. And then finally explain why this statement is true. And I think it's best if you have a visual for this. Okay. So if a goes into here and out here, you get something. So let's just delete this. And of course, if we go back the other way, we should get back to the start. All right. So this tells us go and feed a through the inverse function. So if I feed a back through the inverse function, I'm going to get this box. But then if I feed this box back through the f function, I'll get back to a. So we can just do a picture like this. We can also say that actually the f and f minus 1 are inverse functions. So they undo the operations. That will be okay as well.